Let's consider another example of summation notation. We have the summation of I equals 1 up to 20 of the linear expression 3i minus 4. Now this means that we're going to have 20 values added together, and this can be very time consuming. But let's look at a couple of the terms here. For example, a sub 1, when we plug in a 1 here, we end up with a negative 1. A sub 2 would be equal to a positive 2. Once we plug the 2 in here and subtract, a sub 3 would be equal to a positive 5. Now, note the change that's occurring from term to term to term. To go from negative 1 to 2, that's a plus 3. To go from 2 to 5, that's a plus 3. This is an example of an arithmetic sequence. So what we can do, rather than write out all these 20 terms, we can use the sum formula for an arithmetic sequence. S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. So what we're looking for, since we're starting at 1 and going to 20, we're looking for the sum S of 20 is equal to 20 all over 2 times our first term, a sub 1, which we found here, is a negative 1 plus a sub n. And for our purposes here, we know n to be 20, so we need to find a sub 20. And we can do that by plugging it into our expression. And from this, we obtain the value of 56. Plugging this into our formula and simplifying, we've nearly got it. So 20 divided by 2 will give us 10. 1 minus our 56 will give us 55. So the sum of these 20 terms would be 550.